Hello everyone. This section that we're going to talk about here is kind of tying up the last loose end of graphing lines and things like that, or the last application kind of graphing lines. So after this section we'll move on to different topics that are also important in math, but this will be the last section where we use graphing lines, I think for quite a while, so you won't see graphing lines for a while. I don't know if you're happy about that or sad about that, but there it is. So this section is talking about, as the title suggests, inequalities in two variables. So remember, inequality, that means that there's going to be not an equal sign, but there's going to be, a less than sign or greater than sign, maybe less than or equal to, greater than or equal to, one of those types of things. So an example of an inequality in two variables is here in this first example. This is kind of giving us a warm-up problem, just to kind of get the hang of what these inequalities look like. Now notice that this inequality that I boxed just now, it kind of has the form of a line. It looks like, I've seen a line that looks like that, something x plus something y, or something x minus something y. Although it should be an equal sign here, instead of a greater than or a less than. So it's just like the equation of a line that we're used to, except imagine someone took the equal sign and they threw it away and put a greater than or a less than in there instead. So let's see, just so we know what a solution or a potential solution looks like, let's see if we can do example 1 before we really jump into what the section's all about and what we'll be doing, just to get the hang of it. So the first example, it gives you two ordered pairs. You got -3, 2, and the second ordered pair, 6, -7. And they're asking you if either of them is a solution. So since, I guess, think of an ordered pair as an x value and a y value. So the first ordered pair, -3 is x, 2 is y. And we've seen this before with lines. Instead of, if there was an equal sign in this equation instead of an inequality symbol, what we did in the past is just, replace the x with the x value of the point, replace the y with the y value of the point. And that's exactly what we're going to do here. It's just, when we try to determine whether it's true or false, we'll be just, instead of looking at does the left side equal the right side, we'll be looking at is the left side greater than the right side, because we have the greater than symbol as opposed to the equal sign. So like we said, I'll just take our inequality. I've kind of written it here with the x and the y missing, but since I'm looking at that first ordered pair, I'm going to replace the x with -3 and the y with 2 and see how that looks. Okay, so notice we have 5 times -3, okay, that's -15, and then you're subtracting 4 times 2 is 8. Okay, if you take -15 and you subtract 8, is that going to be greater than 13? I don't think so. Because, okay, let's see. What's -15 subtract 8? That's -23? Doesn't even matter what it is. It's something negative, and something negative cannot be greater than something positive, like 13. That's a no. Okay, so that means that the first ordered pair they gave us is not a solution to this inequality. Let's try the second one, because they want to know about both of them. I'll do the exact same thing, except now the x value of this ordered pair is 6 and the y value is -7. Let's see how this goes. All right, let's see. I'll put the x value 6 where x was in the inequality, the y value -7 where y was in the inequality, and then see if we can simplify that. 5 times 6 is 30 minus, actually it's a negative times a negative, so I'll put a positive. 4 times 7 is 28. We're going to see if that's actually greater than 13. 30 plus 28 is 58. 58 is greater than 13. All right, so that means the second ordered pair is a solution to this inequality in two variables, but the first ordered pair was not. So it's kind of like a yes and no. Yes for the second one, no for the first one. Okay, so if you see problems like that in the homework, you'll know how to do it. That's probably how you would have guessed to do it, because we kind of did things like that in previous sections with just the equation of a line as opposed to inequality. But now that we kind of have the hang of what these inequalities look like and how to see if a certain ordered pair is a solution, let's see what is this section all about. So here we have a little note here. It says, note, there is an infinite number of solutions to an inequality in two variables. They will be all the points on one side of the line or the other. So I guess thinking way back to, remember when we graphed lines, let's say, I don't know, just pretend like I was given an equation of a line over here on the left side, and I graphed it, let's say it looks like this. I don't know. I'm just making it up. So remember, the reason that we graphed lines is to say, look at all those points on that line. There are infinitely many of them. So every single ordered pair on that line is a solution to the equation of the line. And that's kind of why we graph them, because if there are infinitely many solutions, you have no hope of writing them all out. It'd take you literally forever. So we just kind of represent them graphically. And what we're going to do in this section, it's going to be the same thing, but since it's an inequality instead of an equality, it's not only going to be all the points on the line maybe that are solutions, but as it kind of says in this note, what it's going to be is maybe all the points that are above the line, or in this case it kind of looks like above and to the left of the line that I shaded. So all that shaded area, I'm trying to make it so that I'm shading everything above the line. Kind of imagine that shading goes up and up forever and to the left forever. Just never crosses the line. This line goes on forever in both directions. So there's a lot more solutions to inequalities in two variables as opposed to the equation of a line. Because the equation of a line, there are infinitely many solutions, but they're only the points that are on the line. But for an inequality, it's not only the points on the line maybe, but also all the points above the line, or it could be all the points below the line. It'll depend on what inequality we're given. So there are a lot of solutions, way more solutions to these than there were solutions to the equation of a line. But we'll see. So this section, we're not really solving the inequality. You're not isolating x or isolating y like we're used to from chapter 2, was it? Yeah, the last chapter that we were in. That's where we actually solved an equation and we got one solution. But what we're going to do is just represent the solutions to these inequalities as a graph. Because again, there are so many, infinitely many solutions that we have no hope of finding them all and writing them out. So here we have a guideline on how exactly do you graph these things. So how about maybe we'll read them step by step and we'll follow along with the first example just to kind of see what that would look like. Because sometimes when you just read how to do something in math, it's not clear until you actually do it. So maybe that would be a good idea. Okay, so this example here, we're supposed to graph y less than or equal to x plus 2. So let's see what those steps say. The first step up there says you want to first isolate y on the left side of the inequality. But notice in our example here, y less than or equal to x plus 2, y is already isolated for us. So we got kind of lucky. We don't have to do anything as far as the first step is concerned. But if y was not isolated, I would do whatever I had to do, try to move terms around and divide by things, or whatever I have to do to try to isolate y. And you want it to be on the left side, because if y is on the left side of the inequality, it'll be easier to determine, are you shading above or below the line? So it's kind of, that's for step 1, that's kind of the reason we do step 1. And so we'll know which side of the line to shade. So usually you do actually have to solve for y, but in this case we got lucky. I'm kind of going to skip step 1. It's already done for me. The next step, step 2, says you want to graph the line that is represented by the equation that results when changing the inequality symbol to an equal sign. So really what they're just saying there is the inequality I was given is y less than or equal to x plus 2. But just imagine instead of a less than or equal to, or whatever inequality you happen to have in your problem, imagine it was an equal sign. And then graph that line. So now instead of a y less than or equal to x plus 2, I'm picturing this as y equal to x plus 2. And at this point, since you're just graphing the line, you have the freedom if you want to use whatever method. But I notice this is kind of already in that y equals mx plus b form. So I might use the slope and y-intercept to graph this guy. So let's see, the slope, remember, is the coefficient of x. And since I don't see a number in front of x, it just must automatically be a 1. And remember slope you want to think of as rise over run. So I'm going to, even though it was a whole number 1, I'm going to put that whole number over 1 so that I can think of it as rise over run. And that way I'll know how far to go up or down and then how far to go left or right. And then the other component of it is your y-intercept. Remember, your y-intercept always looks like the point 0, b. And b is just the number that's kind of at the end of the equation, adding with x. So it looks like our b is 2. All right, let me see if I can graph this guy. And then in this one, we don't have to worry about this in this one, but I'm going to point it out for future problems. Notice here, part of step 2, it says you want to use a solid line if the inequality was a less than or equal to, or if it was a greater than or equal to. So basically, if your inequality symbol has an or equal to, it has the little line below the less than or the greater than, then you're going to make it a solid line. However, if you happen to have a greater than or a less than, there was no or equal to in your inequality, you're going to make it a dashed line. So, dashed as in, I don't know if when you were a kid, you had a coloring book or some kind of activity book and it said, cut along the dashed line or cut along the dotted line, this kind of thing here. That's what they want. It's just kind of a broken line. Imagine someone erased parts of your line, sort of. So the reason that we do that is because if you have an inequality with an or equal to, like we have in example 2, it's a less than or equal to, or if it was a greater than or equal to, no matter which one it is, it has an or equal to, that means that all the points on the line are solutions to this inequality. However, let's imagine in this problem, what if instead of a less than or equal to, it was just a strict less than? So imagine this was what we were given. Y less than x plus 2, y less than but not equal to x plus 2. That would mean that every point that's on the line is actually not a solution. But it will be, all the points either above the line or below the line will be solutions, but not the ones on the line. I guess the reasoning is because y can be less than, but it can't be equal to. That's not part of the equation. So you only want to count the points that are on the line if you have an or equal to in your inequality, because that means all the points on the line are solutions. So we got lucky in this one. We have an or equal to, so I don't have to worry about it. I'll just make it a regular line. No dash necessary. Okay, so I'll start at the y-intercept. That guy is 0, 2. Here he is. And then from there, we said the slope was 1, well, it was 1, but we put it over 1. So from that y-intercept, I'm going to rise 1. Since it's positive 1, I'm going upward. And then I'm going to run positive 1. That's to the right, because to the right is the positive direction on the horizontal. Okay, so from the point I already drew, I'm going to go up 1 and then to the right 1. Then my point would end up being pretty much just diagonal to the right and above that point. And then I'm going to connect those dots and make a nice line as straight as I can. And in this one, again, I don't have to worry about making it dashed because I had an or equal to in my inequality. Okay, so that line looks good. And the last step is just determining, are you going to shade above or below that line? So let's see, step 3 up here, it says, if the inequality was of the form y greater than or equal to, or y greater than, then you want to shade above the line. However, if the inequality looked like y less than or equal to, or y less than, shade above the line. Oh wait, what? Notice it says above twice. Sorry about that. The second one should be below. Hello. Come on. Sorry about that, guys. So I have to just determine, I guess really what you're looking for is it, like the first line here has greater than. So greater than or equal to or greater than. Either way, it's greater than. That's when you want to shade above. But if it's some kind of less than or equal to, less than, whatever kind of less than, you're going to shade below. But notice in our example 2, it was y less than or equal to. So we're kind of in the boat of the second line, the very bottom line of these steps. It says if you have a less than or equal to, which is what we have, then you're going to want to shade below the line. So I'm just going to do my best, try to shade everything below this line. Try not to cross the line, I feel like a little kid where they say, color inside the lines, that kind of thing. And it should, just to keep in mind, this shading is going to extend down forever and to the right forever. It's just, I guess my graph kind of ends at this point, so I'm not going to shade further. That's how many solutions there are. That's a lot of infinite solutions. It's going on forever and to the right and downward. As long as it doesn't cross that line, you have a solution. Isn't that crazy? That's a lot of solutions. So any point you grab, like here, I'm just kind of grab a random point down here. That's a solution. Anything way over here, that's a solution. This guy's a solution. Anything, even if I were to extend this graph way off to the right or way down, that would be a solution as well. There are a lot of solutions to this thing. It's a good thing we don't have to write them out, right? We just have to represent them with the graph. Alright, so let's try that again with the next one. These, you get the hang of them after a while, because really all you're doing is you're graphing a line, which we've exhausted that topic. Now we're getting tired of graphing lines, right? Probably. So we know how to graph a line, and then the only thing you have to worry about is, do I have to make it a dashed line, or am I okay making it a solid line? And then remembering, when do I shade above and when do I shade below? So that's kind of the hard part. But let's try example 2 here. we have 3x minus 4y is less than 12. And if you remember, step 1 said if y is not isolated on the left side of the equation, you're going to want to do that. And I didn't get lucky in this one. I don't see y isolated, so I'm going to go ahead, subtract 3x over to the right side of this, just in an attempt to try to get y by itself. If I do that, then negative 4y is left on the left side. Oops, I put an equal sign, look at that. Just used to having an equal sign, not a greater than or a less than, huh? Then we'll have negative 4y less than, like it started as, what is it? I could write 12 minus 3x, but remember, we're going to eventually want to graph this line. So I think I'm going to write the negative 3x and then the plus 12 because I want this to look like mx plus b so I can graph it easier. Okay, now the last step to isolate y would be dividing by negative 4, its coefficient. And we've seen this before, it's easier to divide every single term separately by that value rather than the entire left side of the inequality, the entire right side. Now on the left side, y is isolated, but notice that we just divided both sides by a negative number. And remember, if you have an inequality like we have, if you divide both sides by a negative number, or you multiply both sides by a negative number, you have to flip the inequality. So be really careful, that's kind of something that's easy to forget. You got to flip that guy because we just divided by a negative number. And then on the right side, I had negative 3x over negative 4. That's a negative divided by a negative, so it's a positive. And then 12 divided by negative 4 is negative 3. So that looks good. That's going to be really the inequality we want to deal with. Now, actually, at this point, I can kind of forget about the original one. That's not really useful anymore. This is all we need to look at from here on out in this problem. So, okay, that was kind of difficult, or it took a while, but that's okay. The next step, if you remember, was change the inequality symbol, ours is a greater than at this point, to an equal sign, and then graph that line. So at this point, you should always have y isolated, because step 1 was to get y by itself. So in these problems, I think, of course, the easiest way to graph it is to use the slope and y-intercept, because you're going to have it in that form anyway. You might as well take advantage of that, right? So the slope is the number in front of x, 3/4. That means I'll rise 3 from whatever the y-intercept was and run 4. And then our y-intercept 0, comma b, and the value of b is not only this 3, but you need the negative as well. So make sure whatever that sign is in front of b, you keep that sign as part of your y-intercept. Alright, I think we're ready now. I got to keep in mind, because it says part of step 2 is determining whether your line is going to be solid or dashed. So remember, once I look at my inequality symbol, it was a greater than. Pretty much if there's no or equal to as part of your inequality, like ours, we don't have an or equal to. It's a strict greater than. It's going to be a dashed line. So I better keep that in mind, because that's the easiest thing to forget on these, is just to kind of start drawing the line and then think, uh-oh, that should have been a dashed line. And remember, it's a dashed line because there was no or equal to on the inequality. So it has nothing to do with is it greater than or less than. It doesn't matter what direction the inequality is facing. Greater than or less than doesn't affect the dashed or the solid line. Yeah, it's just whether there was an or equal to or not. So okay, now I got to keep that in mind. What are we going to do first? I'm going to look at the y-intercept. 0, negative 3 is down here on the y-axis at negative 3. And then I'm rising 3 and then running 4. Those are both positive numbers, so I go up, which is the positive direction on the y-axis, and then to the right, which is the positive direction on the x-axis, 4. So from that y-intercept, I'm going to go up 3, which is actually going to bring me right to the origin, and then I'll go right 4. So I think that would land me directly above, or on 4 on the x-axis. And that looks good. Now I need to connect those dots, but keeping in mind, the thing I always forget is if it's dashed, I'll just make it solid. Just because we're just so used to graphing lines solid, you know? So here we go. There's a good looking line. Look at that guy. That's a cute little guy right there. Looking good. Alright, then the finishing touch is the very last step. You don't really have to write this out if you want to just kind of keep this in mind. You're going to try to figure out, am I shading above the line or below the line? Well, our inequality, after I got y by itself, our inequality was, it's boxed here, but I'm going to write it again. Y greater than 3/4 x minus 3. So, if you think, you might have a hard time remembering, okay, how do I know if it's shading above or below? For me, the way I think of it is, okay, read this out loud. This is y greater than something. I always think, where are the y values that are greater? the y values that are greater, because that's, the inequality is greater than. Well, if I think about the y-axis, where are the greater or the larger y values? Are they above or below? Are they, they're going upward or downward? Well, for sure, the y-axis has all its larger values upward. So that's how I know I'm going to shade above. That's how I remember it. But if it was a less than, I would say, oh, where are all the y values that are less than? Oh, the smaller y values are down. They go downward, so I'm going to shade below. For me, that's the easiest way for me to remember it, I think. Yeah, so that looks good. I mean, don't feel like you have to fill in every nook and cranny. I think we know what you're trying to do here. If you just shade above or shade below, whatever it is. Just try to make sure it's clear that you have a dashed line there. Sometimes it's kind of hard to tell after you shade. But you know what would kind of cover you as if you just wrote that somewhere. Say this was on an exam and you drew the graph and you said, well, I don't know if it's clear that this line is dashed. Will the teacher know that it's dashed or mark me down? Well, they won't if you wrote the words dashed line here. Then you can't say, oh, I can't tell if it's a dashed line or not. Say, hey, I wrote it. Hello, just to make sure. Anyway, this is fun. Kind of fun. It kind of brings you back to childhood, right? When you used to color for fun. Don't worry, this is going to get even better. With these ones, notice on this third example here, you have two inequalities. So it's kind of like two separate ones. You have x greater than -4, and then you have this guy, y less than -2x plus 3. So this one we have two inequalities. All we're going to do is kind of follow those 3 steps for graphing an inequality twice. We're going to do it once for the top one. Maybe do it in one color, like I'll do it in red maybe. And then we're going to do it for the second one. We're just going to graph them right on top of each other and then see how that looks. It's going to be fun. You can use different colors, bring your color pencils or whatever. I know it's kind of nerdy, right? But okay, so you have to do it twice. I'm going to start with the red one, or the top one. It's x greater than -4. So remember, the first step was you want to isolate y on one side of the inequality, or on the left side of the inequality. But you look at this guy and you say, wait, there is no y. So this one, you can kind of skip step 1. There is no y to isolate, so don't worry about it. Yeah, so just say, okay, that means that I guess I'm done. If there was a y to isolate, I would, but no, I can't. Alright, so I'll just leave it as it is. The step 2 was to change the inequality symbol, which we have a greater than, to an equal sign. So I'm going to write this guy as x equal to -4 and graph that line. So remember, we have to dig kind of deep. It's been a while since we saw this, but remember when either x is missing or y is missing, that means it's going to be a horizontal line or a vertical line. And then remember the way I said that I remember it is, I say, okay, what variable do I have here? I have x. What kind of line is the x-axis? The x-axis is a horizontal line. That must mean I want the opposite, a vertical line. So these guys, yeah, they're the opposite of their axes. If you have an equation with x and no y, then you want to think about the opposite of the x-axis. But if you have, y by itself, or y and no x, then you say, what's the opposite of the y-axis? Y-axis is vertical, so I want horizontal. Okay, so I'm going to draw a vertical line on the x-axis through -4. So I can kind of picture that, but I got to keep in mind, am I going to make this a dashed line or a solid line? I'm going to look back at my original inequality here. It was x greater than -4. So notice there's no or equal to in that inequality. It's just a strict greater than, no equal to. So it must be a dashed line. Alright, so I'm going to try to draw a dashed line through -4 on the x-axis. So I'm going to start here and then draw my dashed line vertical. Very nice. Okay, there it is. And then the last step is to determine, am I going to shade? So this is kind of confusing because the third step says, this is when you shade above the line, this is when you shade below the line. But if it's a vertical line, how are you going to determine what's above and what's below? I guess it's more like what's to the left and what's to the right. So whenever you're graphing a vertical or a horizontal line on these, it's kind of hard to tell. So you know what I would do is probably just kind of use logic. So think about the inequality that we were given here. X is greater than -4. And I'm just going to ask myself, where are the x values that are greater than -4? Compared to this line, are they to the left or to the right of this line? And that'll tell me which side to shade. Where are the x values, because we have an x variable here, that are greater, this can be just in your head, you're thinking this. You don't have to write this out. Greater than -4. But it's kind of useful because later on when you're studying for the final, you might forget, how did I know that I was supposed to shade the right side or the left side or whatever it is? But okay, if I look at this, the x-axis, compared to the line I just drew, the x values that are greater than -4 are off to the right. Everything to the left of that line has smaller x values, but I want greater x values. That must mean I'm going to shade everything to the right of this line. So kind of the above and below shading doesn't really apply to this one. It's kind of a special case, but like I said, you can always use kind of logic. Look at your inequality and say, okay, I want x's that are greater than -4. Where are those guys? Are they to the left or to the right? That kind of thing. Those are a little tricky, but anyway, we'll try the next one here. Now, the next guy we've got y less than -2x plus 3. We're going to graph this just like we did before, but we're going to graph it right on top of the one I just did, the dashed vertical line. Okay, so I don't know why I put a 2. We got to start at step 1. Hello. Although, remember step 1 is to isolate y, and we already have y isolated here. That's nice. So actually, I can skip step 1. Step 2 is now, I'm going to change that inequality symbol. I have a less than, change it to an equal sign. And then we're going to graph that line. So this line looks like the slope is -2. But remember, I want it to look like a fraction, so I better put that over 1. That way I can say what's rise and what's run here. Okay, so from whatever the y-intercept is, I'm going to be rising -2. Since it's negative, that's downward. And I'm going to be running +1, that's to the right. Keep that in mind. And then let's see, our y-intercept 0, b, that'll be 0, 3, because that constant term is 3. Alright, let's see. And then I got to keep in mind too, is it going to be a solid or a dashed line? Well, the inequality here, it's a less than. There's no or equal to as part of that inequality. So it'll be just like the other one, a dashed line. So these both will happen to be a dashed line because neither of them has an or equal to as part of their inequality symbol. Alright, I'll keep that in mind. Now I'm going to plot the y-intercept here. 0, 3 is up here a little bit. And then I'm going to rise -2. So remember, since it's negative, you're going downward. And then I'll run 1. So it's +1, I'll go to the right. I went down 2 to the right 1, and I think, oops, look at that. I told myself I was going to make a dashed line, and then I didn't. So I think that looks like a good line. I'm going to try to connect those dots and make a dashed line. The hard thing is try to make that visible over the graphing you've already done. I'm trying to make these lines thicker, I guess. Alright, that looks good. And now I have to determine, the last step on this is, am I shading above or below that line? And this is where I can look back at the original inequality I was given here. So y less than -2x. Remember the directions said if it's less than, you can kind of reason it out. Y less than, where are the y values that are less or smaller? On the y-axis, the small y values are downward. That must mean I want to shade downward, everything below this line. But if it was a y greater than, or equal to even, I would shade above, because the greater y values are above, or upward, I guess. Alright, I know that looks like a mess, right? But just kind of the main thing to remember on these is, if you have two inequalities together like we have, the solution to the whole, I guess this whole problem, because what you want is, you want only the points that are solutions to the top inequality, the red one, and the solution to the green inequality as well at the same time. So really, technically the solution is only this area that's shaded with both colors. So that's what I should do. And when you do your homework too, that'll be the thing. So you're going to, like, let's say this is a problem on the homework. You're going to do it on scratch paper, of course, because you want to be careful and safe and all that. But when you go to actually graph this on your homework, I'm going to kind of redo it here. You're going to plot one line, of course, making sure it's dashed. Let's say I kind of do that one more time. And then the other one looks something like this. But when they ask you where do you want to shade, you're only going to shade what they had in common. So this is like my scratch work here. This is what I've done so far. But my actual solution should be more like what I'm drawing to the right of this problem. I'm only shading what's kind of between the two lines, between and below the two lines. Because that's the only place where both, I guess both colors were together. I only saw red and green together in this area. So be careful. You can, it's probably a good idea to do this, like I said, on scratch paper just to get the hang of it. But then once you're kind of giving your final answer on the homework, you're only going to shade what they have in common, not all the shading that we did. So be careful on that one. That's a lot of work, huh? So let's do a few more of these to get the hang of it, and then I think you'll be kind of ready to go on your own here. Alright, so notice the next one, they're giving us more of this where we have two inequalities. I'm going to have to do the same thing. The first one, or the top one, I'm going to look at first. Y minus 2x greater than or equal to 1. Alright, and this one, unfortunately, I do have to solve for y. They weren't nice to me. But it won't take too long. I'll just add the 2x to the right side. Alright, that wasn't so bad, I guess. So it's y. And I didn't multiply or divide by a negative number, so there's no need to flip the inequality backwards. It's going to stay a greater than or equal to. And then I'm not going to write 1 plus 2x. I'm going to write 2x plus 1, because I know I'm going to be graphing this line, and I want it to look like mx plus b. Looking good. Alright, the next step is step 2, change the inequality symbol to an equal sign. Make it y equal to 2x plus 1, and then graph that line. So this, you're going to be graphing so many lines, it's going to be easy for you after a while, if it's not already. So what do we have here? The slope is the coefficient of x, 2. But like we've seen a lot here, we want the slope to look like a fraction. So I'm putting 2 over 1, and I'm going to think of the numerator as the rise and the denominator as the run. And then my y-intercept is going to be 0, 1 in this case, because that's the constant adding at the end. And now I have to think about, is this going to be a solid line or a dashed line? Well, looking at the original inequality, it was a greater than or equal to. Notice there was an or equal to. So this guy will be a solid line. Just make sure you kind of try to memorize that. That yeah, when you have an or equal to, it'll be a solid line. If it's a strict less than with no or equal to, or a strict greater than with no or equal to, that's when it's a dashed line. But okay, let's see. I'm going to start at 0, 1 for my y-intercept. And then I'm rising 2, that's positive, so I'm going up, and then to the right 1, because that's the positive direction. And I don't have to worry about remembering to make it dashed, because this is a solid line. There it is, beautiful. Good looking line, sort of. And then the last step for just this inequality is I have to determine, am I shading above or below? So I'm going to look back at when I solve for y. Okay, I got y by itself. Y greater than or equal to 2x plus 1. Now I can use my reason. I can say, where are the y values that are greater than? Or where are the large y values, greater y values? Well, they're always above. The y-axis has this largest y values above, or upward. That means I must want to shade upward. So it's everything above this line is your solution here. Well, so far. That's for that inequality. Now we have to look at the other one. Alright, I'm going to do the other one in green. The other one looks like y minus 2x less than or equal to 3. Alright, and this one I don't quite have y by itself. I'll actually have to do that first step. But that won't take too long either, huh? It's the same first step that we just did in the previous inequality, adding 2x. It's kind of interesting. Looks like y, and I didn't, like I said before, I never multiplied or divided by a negative number, so there's no need to flip the inequality backwards. But if in the process of solving for y, I did divide both sides by a negative number, or multiply both sides by a negative number, then you would have to flip it backwards. So there's my inequality. Alright, looking good. Now I'm going to, like step 2 said, change the less than or equal to, or whatever your inequality is, to an equal sign. And then you're going to graph that line. So I notice this one, I have the same slope as the last inequality. I'm going to make, it's a 2, but I'm going to write it over 1, so I can think of that as rise over run. My y-intercept's different though, 0, the constant term in this one happens to be 3. Okay, so I'm going to graph that line, but let me think about, is this going to be a solid line or a dashed line? Well, the inequality we have here, y less than or equal to. There is an or equal to. So this guy will be a solid line as well, just like the last one. Sounds good. Alright, so it's going to be another solid line. I'm going to start at the y-intercept at 3. Here it is, kind of in the thick of all the red shading. Then I'm going to rise 2 from there, that's up 2, and then run 1. So it'll be, then of course it looks like those lines, or those 2 points have the same slope as the other line. Of course they have the same slope. We've already written it out, right? The slope was 2 over 1, which is the same as the other one. Now I'm going to connect those dots and draw a solid line. Try to make it straight. So these lines are parallel, huh? Interesting. Okay. The last step here for this inequality is I have to determine if I'm shading above or below the line. So I'm going to, once I solve for y, I'm going to rewrite that inequality. It was y less than or equal to 2x plus 3. And I'll just ask myself, where are the y values that are less than or equal to. Lesser y values are downward, right? I'm going to shade everything below that green line. And of course, kind of ignore the red. You can just go over the red or whatever it is. Just imagine there was only green here, or your only line is your green line. But remember, this is your scratch work, so if you go and do your homework, the only part I'm shading really is what they have in common. So what I would do when I'm actually doing my homework is I would graph one line, okay, say that's the green line there, and then the red line was a little bit below it. He looks like that. But notice, where do you see both shadings together? You only see it in the middle, between the lines. So I'd only be shading here between the lines. That's the only solution. Not above because there's only red, and not below because there's only green. You want where you see both colors at the same time. And that's why I think it actually is a good idea to use color pencils or two different colors. Maybe use a pen and a pencil if you don't feel like bringing your color pencils out. That would work. Alright, sounds good. I think we got one more here and then we can call it a day. You guys have been very patient. You're always very patient. I appreciate that. Alright, got one more, and of course they're giving us two inequalities again. That's nice. Alright, we got one here. I'm just going to start with that guy. Negative 4y, and then what is it? Plus 3x, less than or equal to 12. Alright, y is definitely not by itself. I better go ahead and try to make that happen. If I want to isolate y, I'm first going to move this 3x over by subtracting it. Then I'll have negative 4y, and I didn't divide or multiply by a negative number. I know it looks like I did something with a negative, but I didn't divide or multiply, so I'm not flipping the inequality. And I'm going to write the 3x first and then the 12, because we want to make sure this looks more like mx plus b. And then the last step to try to get y by itself will be to divide by negative 4. Every single term. And at this point I have divided by a negative number, right? That means I have to flip this inequality. It's no longer less than or equal to, it's now a greater than or equal to. And the next term I have a negative 3 over negative 4, that's positive 3/4 x. And then a 12 over negative 4, that's negative 3. That looks good. Alright. And now the next step for this inequality is change that inequality symbol to an equal sign. Now it's y equals 3/4 x minus 3. And graph that line. The slope there is the coefficient of x, 3/4. So wherever happens, I'm going to rise 3 and run 4. And the y-intercept is 0, the constant term is negative 3. So that'll be your y-intercept. Alright, and then I got to think now, before I graph this line, what's the, or am I going to have a solid line or a dashed line? Well, the inequality symbol was greater than or equal to by the time I solved for y. There's an or equal to in it, so that means it's going to be a solid line. I kind of made it not look like it had an or equal to, but remember, it did have an or equal to. Let's go for it. I'm going to graph this line. Starting at 0, negative 3, here he is. From there, we're going to rise 3, because that's the slope, and then run 4. So up 3, oops, that'll get me to the origin, to the right 4. There he is. That looks good, and it's a solid line, so I don't have to worry about making it dashed or anything. Just a normal kind of solid line we're used to. Alright, the last part of this inequality is I'm going to look back. Once I solve for y, it looked like y greater than or equal to 3/4 x minus 3. The inequality is a greater than, so I'm looking for where are the y values that are greater. Well, the y values that are greater on the y-axis are upward. Those are the larger y values, so I must want to shade above the line. There we go, that looks good. Alright, we'll do that one more time for the next one. And I'm looking at this guy, he looks a lot like his friend above, huh? Instead of negative 4y plus 3x, it's 4y plus 3x. I have a feeling these guys will be interesting graphs. Like the last ones were parallel, huh? This one might be something kind of interesting as well. 4y plus 3x greater than or equal to negative 36. Alright, and this one I really do have to solve for y. Same first step. I'm going to move the 3x over first by subtracting it. And then we'll be left with positive 4y greater than or equal to, because I didn't multiply or divide by a negative number. I'm going to write negative 3x and then negative 36, because you want it to look like mx plus b. And the last step to isolate y will be divide by its coefficient 4. Every single term gets divided by 4. But notice in this one I'm dividing by a positive number. In the previous inequality I divided by a negative, which made it so that I had to flip the inequality. This time though I'm dividing by a positive, so there's no need to flip the inequality. And then on the other side, you have a negative 3 over positive 4. That's a negative. I'll just put negative 3/4 x. And then a negative 36 over positive 4. That makes negative 9. All right, there he is. That's a good-looking inequality. And then I'm going to look at, oops, the second step. I don't know why I labeled that first step, step 2. Okay. Step 2 now. I'm going to change that inequality to an equal sign. Y equals negative 3/4 x minus 9. And then start identifying, okay, what would the slope be? What's the y-intercept here? So my slope, negative 3/4, because that's the coefficient of x. But remember, when your slope is a negative fraction, you want to assign that negative to either the top or the bottom. But we said we just always put it on the top so we don't get confused or forget where to put it, you know? So I just always do that. I'm going to give the numerator the negative. Denominator can just stay positive. So that means I'm going to rise negative 3, that'll be down from whatever the y-intercept is, and then run 4. Positive, so I'll go to the right. And the y-intercept is going to be 0, comma, the constant term here is negative 9. Looks good. Now I have to determine if it's going to be a solid line or a dashed line. Let's see, when I got y by itself, this was my inequality. The inequality symbol is a greater than or equal to. Since there is an or equal to component to that inequality, it'll be a solid line, just like the last one. Alright, let's start at the y-intercept, negative 9. Oh, that's way down there. 0, negative 9, there he is. And from there we're going to rise negative 3. Uh-oh. This is one of those situations, I'm kind of going off the grid, literally here. I'm just going to extend that grid to go further down. Don't feel like you can't do that, that's fine. I have to go down 3. Okay, so I'm going to count 1, 2, 3. There it is. And then we're running 4, but that's positive 4. So I'll be going to the right. 1, 2, 3, 4. Right about there. Let me plot my other point. There he is. Oops. Hello. Oops, I want a green. Hello. There it is. Looks good. And then we'll connect those dots, and it's solid, so I don't have to worry about making it dashed. There it is. And try to extend your line as far as you can, because you want to see where they meet and kind of what the graphs have in common, where the shadings intersect. Because I have seen students, they'll draw these or when they graph these problems, let's say this is your x and y coordinate system, they'll go, oh, one line looks like this. It's a really short line. And then they'll shade. The other line looks like this. And then they'll shade. And then I'm like, you can't tell where they intersect if you make your line that short. Of course, the arrows indicate it's going up, up and down forever and all that. But the whole point of this is to see where the shadings intersect, and you can't tell. So try to make your lines, extend kind of as far as you can so that you can tell where the shadings intersect. Don't be silly. Don't try to save. I mean, it's good to save ink, I guess, in your pen, but come on, don't be silly. All right, where are we shading, though? Are we shading above this line or below this line? Well, what was my inequality by the time I isolated y? It was a greater than or equal to. Alright, so again, this is the reasoning here. Y, where are the y's that are greater than or equal to? The greater y's are above. That means I'm going to shade everything that's above this green line. There it is, looking good, okay. Alright, now that I've shaded those, I can see what they have in common is kind of the top kind of quadrant that these guys chop the number line, or the Cartesian coordinate system into. So when you do your homework, the actual solution to this guy would be you'd only shade above and to the, above both lines. So when I graph my red line, he looks something like this, And then I graph my green line, and he looks something like, oh man, this is looking nothing like my graph, but I'm pretending. Something like that. But the solution is only the portion that they had in common, so all this stuff up here in this top corner, sort of. I'm not going to shade down here because that was only green. I'm not going to shade here because that was only red. Just that portion there. So that's how you graph inequalities in two variables. Hopefully that made sense. It's kind of a lot of fun because you get to be a kid again and color, which is kind of nice, going back to your childhood. But that's kind of all the coloring we're going to do. Now we're going to move on to the next chapter, start something new, and I think you're going to like it. It's kind of a nice welcome break. Sort of simple, you're going to almost not trust it. It seems so simple, but it's leading towards something interesting. So I'll see you in the next video. Thanks for paying attention, and have a nice day.